valuable source of proteins and nutrients in the diet of many in Kenya, is now coming up to be fish. The contribution of fish to food security, therefore, is rising significantly. Currently, 200,000 people depend on fishery resources directly as a source of employment. About 1 million derive indirect benefits from them. Kenya produces approximately 200,000 metric tons of fish and fishery products per year, valued at about 6 billion. Most of the fish is produced by over 40,000 fishermen, mainly artisanal, operating about 11,000 fishing boats in both inland lakes and marine waters of the Indian Ocean. Fish exports from Kenya are mainly from the freshwater fisheries of Lake Victoria, where Nile perch leads. Fish, however, spoils very fast, hence the need of immediate preservation. In the Lake Victoria and the coastal areas of Kenya, fish, for other than immediate local consumption, is in the absence of cold storage, preserved by salting, sun-drying, or smoking. Fish preservation in Kenya must be elastic to involve newer techniques than the traditional methods and thinking currently in place over the years in most areas. Most of the artisanal fish producers do not have refrigeration, hence wastage of fish once caught is inevitable. With high levels of protein deficiency in diets, ways must be put in place to utilize fish that goes to waste as fish bycatch, non-conventional fishery, or underutilized fish owing to shape, appearance, or physical features like being bony, hence difficult to eat. Fish bycatch has been a problem for some time in Kenya, especially in the prawn or shrimp fishery. The ratio of prawn or shrimp catch to bycatch is 1:7. Kenya cannot afford to see much needed protein go to waste and has to devise methods that can enable her to utilize this bycatch. Fish processing industries also yield fish waste that can be utilized to make other products of higher economic value. One of the methods that can be used to process fish bycatch, underutilized or low-value fish and waste byproducts from fish processing is by extrusion. Extrusion technology is essential to value addition to agricultural commodities, especially cereals or legumes, to enhance food security and sustainable development. It is a powerful processing operation which can produce products with unique textural properties, having high and low density, as well as highly expanded and condensed products depending on the processing condition. A low-cost extruder was designed by scientists in the Netherlands, led by Dr. Paul Bartels, in a collaborative EU project including countries like India, Malaysia, Namibia, Ghana, and Kenya. The coordinator of the project was Professor Nazlin Howell of the University of Surrey. Other partners were from Portugal and Argentina. In Kenya, the lead partner institution was Kemfree, with a technical assistant from JKUAT.
One of the things we have seen in the past is that for processing, an extruder is very useful. An extruder is a continuous cooking machine, a continuous pressing machine. It's a screw that's continuous bringing the material through a house which is heated. And by cooking, we can make it digestible and giving shapes. It's also, we can press it also that it will expand afterwards, and then it's easy to dry and to mill. And then you can put it to all types of other food. So a long time ago, we thought we had to create an extruder that everybody can use, that's very cheap. We create an extruder for material that everybody can buy everywhere. So the design, or original design, was thought to be a part of the agricultural system, being at the end of a tractor, but finally it was easier to create an electric drive to it and bring it to inside a factory. Still, it's a simple extruder, an extruder that can be built from a Toyota wheel and from all types of materials that you simply can buy and simply can mechanically change. It's also very cheap. Well, this extruder is now used at several places in Africa and Asia. It's designed in Wageningen, and there's also one extruder in Wageningen for that reason, the original one. But there is one in Accra, there is one in Namibia, there is one nowadays at Peshwood in Kisumu, and there is also one in India, Mangalore. So, all from the same design.
Extrusion is a process that combines several unit operations, including mixing, cooking, kneading, sharing, shaping and forming.
We know there are many extruders which are made, but extruders are made for various purposes, for air extraction and for also making various molds. But this particular one is meant not only to do that extrusion and form a certain shape, but also it is meant to cook the food, or to increase, as we increase the temperature, it is actually cooking the food as it passes. And you can see it's a long one here. Secondly, we are able to use different nozzles. This nozzle, we can get various shapes. This one is a nozzle we can replace to get various shapes. And we begin by putting the product here, and it goes through this process until it comes out here. These are various components of the extruder. Now, we want to check the temperatures at which it performs best, or how much we are doing this and it. To do that, we have heaters installed at these 2 points. That is the inlet and the outlet. These are supposed to heat the whole extruder, and we want to check whether we can maintain uniform temperature.
These are the temperature control panel to the heaters on the screw jackets. We have set value. The one in green color is the value that has been set, such that when the temperature we raise and gets to 80, the red, when it gets to 80, the control stops there, cuts the power. But the value can be changed depending on the desired value you want. The machine is an electric-driven machine, 3-phase powered, and the motor is a 10 horsepower motor, which is down there. Once it gets the power draws the power from the line, the machine runs. Of course, when I've switched there, it will drive the gearbox. The gearbox is a reduction of the speed so as we gain torque. And then there's a further reduction because we have a mechanical speed reduction through pulleys, and then the drive is through the belt. And you can see this one, you have 6 Class B belts. And eventually now the bigger pulley here is the one connected to the screw, drives the screw inside. that the screw is the transmitter. It will transmit any material now hopped in this hopper, and all the way, and the heater will have heated the jackets. Then the food will be baked inside, and as it travels via the screw mechanism all the way to the exit. And the exit is a die which will determine the type of the shape you want and the size. You can change the whole size here to get bigger nodules, or you can minimize, or you can make it square or any other shape you desire. And the end product will come through here. This is the final point that the food will come through. And now it will come as a long, continuous extruded material. And now you can cut to size depending on how you want them taken to the market.
Extrusion is applicable in fish processing to produce value-added products. The fish product, fish by catch, underutilized fish, byproducts from fish processing are therefore mixed with staple cereals like maize, millet, rice, cassava, etc. to produce dry and dried shelf-stable extruded fish products like instant porridge for use in infant formulations, snacks, noodles, and floating feed for use in fish farming.
The motivation for this project, therefore, was to try and utilize the particular low-value fish which are thrown away, to see if they can be brought back into the food chain by making various shelf-stable products. Now, to do that, the low-value fish are supposed to be mixed with staple cereals like maize, grit, or rice, or any other carbohydrate products, mixed together at particular ratios and at particular moisture contents, fed through the hopper, and the product that will come out here will be semi-cooked and will be shelf-stable because it's passed through some heating process, and that is the one which can now be used to either make or avail a new product in the market which is now fortified with protein. So you are having carbohydrates which don't have protein, you are putting in protein which was wasted and ending up with a product with protein and carbohydrate completely to solve out some nutritional problem.
To promote private-public sector partnership, Kemfree and a new partner in the project representing the SMEs Pech Food in Kisumu are working together to roll out some of the value-extruded fish products, both from human nutrition and fish nutrition, which faces challenges due to lack of floating feeds that can now be produced by the extruder through extrusion cooking.
I think that it's very unique and very interesting for us because what was happening is that you take a lot of research that is done, and with working with academia, working with the engineers, and working with people from University of Surrey, from the business point of view, you look at it with a very different, through a very different lens, because when you're doing business, all you look at is the bottom line. And I think when you're doing research, you're actually spending the time finding out what's happening. So I think this model that we're working with in Secure Fish is great, because whatever is being researched can now be commercialized, and so I think for us it's quite interesting as well, because we would never spend or have the kind of knowledge that we are receiving as being part of this project.
Pech Foods is a processor of Nile perch with the inevitable waste byproducts. A portion of this waste, which is still rich in protein, will be used to fortify cereals like maize, cassava, millet, ecto-produce shelf-stable products with that extra protein. These products shall include extruded fish products like instant porridge for use in infant formulations, snacks, noodles, ready-to-eat foods, and floating fish used in fish farming. For some populations in Kenya also that do not eat fish owing to the appearance among others, an opportunity will be provided for them to have fish in their diets in a different form. To achieve sustainable outputs, the strategy of Kemfree partnering with an SME like Pech Foods is quite workable in private-public sector partnership, because Pech act as the source of constant raw material supply and market, while Kemfree act as the source of technical input, especially the recipes. The other partners in the project, led by Malaysia with the expertise of Dr. Chiwi Seng, will provide more information on recipes, with the experience from Namibia and Ghana coming in handy.
But we need that as much as possible is really used. So we have to cook it. Therefore the extruder is needed to cook the cassave, to get the starches really available for the fish.
Since this was the first time extrusion cooking was being tried out at SME research level, capacities building through practical demonstrations were carried out by Dr. Paul Bartels. One of the main purposes of extrusion is to increase the variety of foods in the diet by producing a wide range of products with different shapes, textures, colors and flavors from basic ingredients. With extrusion cooking, the total utilization concept of fish where nothing is wasted can therefore be achieved. In general, single screw extruders like the one in use here provide adequate operating ranges and are cheaper to purchase than twin screw extruders, meaning that startup costs are less. With the availability of low-cost extrusion equipment, processing of cereals and legume-based products are feasible. There is no doubt that the application of extrusion to traditional African foods can lead to the diversification of new and novel foods, which can result in increased usage of the technology for sustainability. Furthermore, extrusion cooking will bring increased utilization of local raw materials, industrial development, and creation of income, coupled with the possibility of producing various biopolymers as raw materials for sustainable thermoplastic materials. Proper implementation of research efforts will boost food production, result in poverty reduction to enhance promotion of provision of food security, among others.